Alright, so I was messing with Turtle a little bit in Python, and in that video I kind of got bored of it. Honestly, I didn't really accomplish much, but you know, now I kind of want to take a look at something special, I think, in my opinion, um, which is this. Let me try. Um, I want to understand how this code works and how complex it really is. Um, File path. It's just here. Zeta.py. It's right here. So if we can analyze this, right? I mean, I feel like this is gonna be using up a lot of other classes that we don't know of, and like a bunch of methods that we don't know of. So it would take a while. But the thing that I wanted to do was code something like this in Turtle, which I don't. Can you plot a complex number? Yes, you can plot a complex number. Okay. So if that's the case, okay, I think this should be pretty easy then. All right, import turtle, import numpy. Wait, no, from numpy, import zeta. Is that how you do it? Or is MP math? Okay. So what I want to do is first make a loop. Let's say I less than 1000. So it goes through 1000 points. And I think that might not be too much, but we'll see. Another thing we have to do, wait, hold on, let me just finish this. While I equals 0, um, wait, does it have to be like this? I don't know, I forget. I don't know. Oh my gosh, I don't get the syntax. Okay, that's the syntax. While I less than 1000, I plus equals 1, then um, we take, um, then I want to create a graph with turtle.py. so we need this line. We need this line by default. Probably need these two lines. Wait, maybe these three. Wait, actually, for these 4 lines, do black. Then you just plot each dot, right? So actually, don't put the pen down yet. How does this? What I want to do now. Let me see in here. Okay, hold on. What is CTX? Okay, I do not know what that is. What is this? Hmm. How do you use Zeta from MathPy? Or is it MathPy? I don't know. MP Math. I'm at. Bro, I don't get this. Why did it tell me to import Zeta in another somewhere else? Okay. So we'll just copy this then instead. Fuck, man. And then I need this line right here. What is precision digits? I don't know what that is, but we'll just copy it. And then 0.5, that's actually what we need. And then we do S. Wait. S plus equals 1j. Is that actually how you do it? So then it increases. But then in this, it increases by decimal. So this would be like a lot. This would be a lot. And this. I don't get this shit, man. Okay. And then someone's calling me. Okay. Now, what do I need to do next? I need to plot this. How to plot a complex number in turtle. Yo, this is rough. We need this. How come it's not? I don't get this shit, man. Turtle dot done. Yeah, that's exactly what I have here. Ow. I mean, we could copy this, but that's just vibe coding at that point. Turtle has no attribute. What? Oh. Let's go like this then. That should work. Whoa. That is cool. That is AI for you. AI can do that, by the way. Um, complex number. I mean, if I just copy this, I am vibe coding at this point. Like, vibe coding so hard, it is not even funny. And then instead of printing this on the terminal, you would just um, so let's see what happens. Okay then. That is not what I wanted. Ah, man. I wonder why this doesn't work. Let's just ask ChatGPT. Let's vibe code so hard. Let's go, bro. About to vibe code. Okay, let me go. Okay, vibe coded done. I mean, this is probably the solution, but you know, what, bruh, that's it? Huh? That just looks shit. That looks so shit, bro. We'll see. There you go. That was some of it. You see, what's the point? What's the point of knowing how to code when AI can just code for you, man? It's just fucking pointless. But yeah. If I had to explain my understanding of the zeta function, right? And like, say you didn't understand what it is, and or you just don't even really have an understanding of math. Um, Honestly, I think it's interesting because it's part of the Riemann hypothesis. Riemann. I don't know how you say it, but first of all, the hypothesis is that um, all real parts equal, or just put equal, uh, equal 1/2 uh, at the non-trivial zero. All real parts equal 1/2 at the non-trivial zero of the zeta function. If you can even read my handwriting. That is Riemann's hypothesis. And so this basically has implications for real numbers. Um, and so far, billions of numbers have been proven to lie on what is called the critical line, and which is 1/2. Um, uh, and so far, no one has disproved it, and that is just to remain a mystery. Like, is it true? Is it not true? And honestly, I find it quite interesting. Um, just because it's just a mystery, and like mysteries are cool. Um, and what a non-trivial zero is just uh like f of x, right? X is like kind of, you would say, I guess, a real number most times. Um, um, but like what it's saying here is like f of x plus something like I. It's like a real number plus an imaginary number, which is a complex number. Um, uh, and this would have to equal 0. So a complex number that makes the function equal 0. And the thing about a complex number is that it's on a 2D plane, right? Um, a real number is always on uh, the x-axis, and the imaginary number is always on the y-axis, and that's just how it is. Um, so yeah, that's just a fun fact. I mean, honestly, so this is what the function looks like. Um, I don't even know why I remember it, but I think it looks like this, and equals 1, infinity. Um, uh, and wait, 1 over, no, wait, I'm quizzing myself on this right now. I think it's 1 over n over s. I think that might be it. And then that just equals 1 over n over s plus 1 over 2 over s plus 1 over 3 over s, and so forth. Um, and then there's this here that you plug in as, and then that. So that's the function. So it's the summation to the upper limit of infinity, and I don't know, I forget what this is called. What is n in a summation? Oh, lower limit. Okay, lower limit. So upper limit, lower limit. Easy to remember, upper, lower. Um, and if I fact check myself, yeah, I was right. See, okay, it really, it's a very easy function to remember, but um, still very interesting. Um, okay, so then there's this other thing. Um, what S is like supposed, so first of all, the implications, if we move on, right, the implication of n 1 over n over 1 over n to the power of s implies that you're taking an exponent of a complex number, and that implies Euler's formula. Um, Euler's, um, and Euler's formula, I actually have a hard time understanding, but basically, um, Euler was like Um, he just found the um, I think he found the connection between complex um, I think it was E the uh, I theta or something, just an angle, right? Um, is just he just figured out that e to the I theta is just a rotation on the circle. That's what he figured out, and that's what n to the s to the power of s implies, I think. So yeah, that's what I know so far. Um, and yeah. Um, but honestly, I'm just bored of just what's the point? What I would need to do right now is I'm actually there is this research paper. Um, if we go here, implications of predicting predicting non-trivial zeros and quantum. This one. Um, there's there's a paper of something. There's a paper of something regarding the connection between the zeta function and quantum mechanics. And the connection was that um, uh, the non-trivial zeros appeared in a way that was similar to physical quantum mechanics or something. I don't know, but uh, um, where's the paper is my question. Yes, this is interesting. The thing is, I don't know much about quantum mechanics, so I need to do research on quantum mechanics to get a better understanding of this and to just be able to wrap my head around Riemann, the zeta function. I just, I don't know, I just don't feel like it for some reason. I don't feel like it for whatever reason. I just don't feel like it. Mm, do I feel like doing right now, man? Honestly, I'm having an existential crisis right now, man. I don't know what to do. Let's have a chat with ChatGPT. Let's talk with ChatGPT. Because I'm lonely. Where is... where did it go? Where did it go, bro? Okay, this one. Isn't this, sigma? Let me see. Isn't this sigma? Or lambda? Oh. What is sigma then? Oh. I don't know, I'm bad. Okay, this is... I do not understand this, bro. Linear algebra feels like is... Linear algebra, I mean... In linear algebra, an eigenvector or characteristic vector is a vector that has its direction unchanged by a given linear transformation. Interesting. More precisely, an eigenvector v of a linear transformation t is scaled by a constant factor when the linear transformation is applied to it. Corresponding eigenvalue is the multiplying factor. So an eigenvalue is constant. Is an eigenvalue an irrational? Shit, I felt like I spelled it wrong. Oh my god! No way! It's irrational and a constant value. I don't know, man. It shouldn't be that mind-blowing. Are all eigenvalues irrational? No, not all. It can be integers rational or irrational, and can even be complex numbers. For example, a matrix with all. Okay. But how could it not? So what integer is an eigenvalue? But not all eigenvalues are integers. When a matrix has an integer entries, its eigenvalues are guaranteed to be algebraic integers. If a rational eigenvalue exists, it must be an ordinary integer. In linear algebra, an eigenvector is a vector that has its direction unchanged by a given linear transformation. More precisely, an eigenvector v of a linear transformation t is scaled by a constant factor. Wait, so eigenvalue can be matrix. Wait, in the equation AV, where AV, wait, A equals A, eigenvalue V, or what? I don't get it. Where A is the matrix, V is eigen. I don't get it. Eigenvector equals eigen. Bro, I don't think these... But how can a eigen... How do you even pronounce this shit, bro?
Eigenvector.
Eigenvector. How can an eigenvector not change when it is a int? Alright, we'll stop here. It's interesting, but you need to stop.